problem solving. So today I'm trying to solve this problem called 3n+1 on UVA Online Judge. So let's navigate to the location of the problem first. So you just go and search for UVA Online Judge, then hit on Browse Problems, go to Problem Sets, volumes 100 to 1999, go to Volume 1, and here's the problem. Okay, so let's start understanding the problem first. So first step in any problem solving is to understand the problem and the constraints. Okay, so here in this problem, you'll be analyzing a property of an algorithm whose classification is not known yet. And the classification could be non-polynomial, unsolvable, recursive, etc. Okay, so what is the algorithm? If you see this, it says input n, print the number n. If n is 1, stop. If n is odd, multiply it by 3 and then add 1. If it is not odd, then just divide it by 2 and set it back to n. Then go back to step 2 and keep repeating this until n goes to 1 and then stop. For example, let's say take 22. So with 22, we just print the input first, print n, and then go if n is 1, no. Is n odd? No. It is even, so you divide by 2, and then you go back to 2. So you print it, and then is it 1? No. Is it odd? Yes, it is. So you multiply by 3 and add 1, go to 34, print it, and then keep repeating the same thing. So let's just go to the steps directly. So 34 is even, so divide by 2, 7 goes to 17, which is odd. Then multiply by 3 and add 1 goes to 52, which is even. Then you divide by 2, make it 26, which is even. Divide by 2 again, makes 13, which is odd. Then you multiply by 3 and add 1, makes it 40, and then it is even. So divide by 2, 20, again divide by 2, then again divide by 2. Now you got an odd number, so it becomes 15 plus 1 is 16, then which is even, then goes to 8, which is even, then goes to 4, again even, goes to 2, which is even, then goes to 1, and reaches step 3. It says if n is 1, stop. So for a given n, this is called the cycle length of n. In the above example, cycle length of 22 is 16, so let's see if it is 16. Start with that number. 22 is 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, which is what this one says. 16 is the cycle length for 22. Okay, so the problem goes further to say, despite the simplicity of this algorithm, it is unknown whether this conjecture is true. It has been verified, however, for all integers n such that n is between 0 and a million, and in fact for many more numbers than this. So it says there is a cycle length for each of these numbers between 0 and a million. And the problem asks us for any two numbers I and j, you have to determine the maximum cycle length for all numbers between and including both I and j. Okay, so let's go to sample input. If the sample input is 1 and 10, which is a pair of integers, the output is supposed to be this printed as the same number of integers, same integers, sorry, and then the maximum cycle length between these two numbers and including them. And you keep doing this for all the pair of numbers and keep printing all the outputs. That is what is expected. And now let's look at the constraints. So the first constraint is all integers will be less than 10,000 and greater than 0, which is good. Then you can also assume that no operation overflows at 32-bit integers, which means that when you multiply it by 3 and add 1, there will be no overflow of a 32-bit integer. So these are the two constraints. So I'm hoping that you understood this problem and understood the constraints, which is the key component in trying to solve a problem. So let's look at the solutions in the upcoming videos. Thank you.